This lesson is for FST Lesson 9.5, Log Properties. Students should be only using a baby calculator for these properties. There are 5 of them altogether. The first one has a variable or a number in front of a log problem, and that variable or number can be manipulated and turned into an exponent on the thing that you're finding the log of. This property is very important, and it will be used in the next lesson for solving with logs. Today, most of the time that you're going to be working with it, you're just going to move the n to turn it into an exponent, but know that you could use the property in either direction. When we look at it in 9.6, the exponent will move to the front. Today, the problem that we're going to do, it's going to become an exponent. The next property has the log of a base. When you take the log of that same base to a power, I'm sure students are probably already comfortable with the fact that that power then is the answer. So we're not really going to do a whole lot with that particular property today because we've been utilizing it all along. Another one that students are probably already familiar with is when you take the log of a number, the only way to get a 0 or the only way to get a 0 power is, or the only way to get a 1 for your answer is if you use a 0 as the power. So if you take b to the 0, that's the only way you can get the answer of 1. So if you take the log or the natural log of 1, you're always going to get a 0 back. And students have been working with that idea all along as well. The next 2 properties kind of go together. They're very similar in terms of how you're going to utilize them. If you look on the right of each of those properties, there's 2 logs put together with either a plus or a minus. And the way that we're going to simplify those is turn it into a single log problem with either multiplication or division. So it's important for students to remember that addition of 2 logs turns into multiplication with 1 log, just like subtraction with 2 logs turns into division with 1. It is important on the subtraction and the division property that you go in the right order. When you're doing log of x minus log of y, to turn that into a single log problem, you have to do the x in the numerator and the y in the denominator. If the book asks you to name any of these properties, you can just look those up in your textbook. I am not going to require students to memorize the names, simply just to utilize the properties and implement them in the proper way. First example clearly has addition in it. Make sure that the bases are the same. If they're not the same, then you can't use the addition property. The addition property says to turn it into a single log problem and use multiplication. So I'm going to write out 2 times 108. And then you should try to simplify further if you're able to. So 2 times 108 is 216. And I know that I can rewrite that in exponential form. So 6 to the what is 216. So then I would do some trial and error with the baby calculator. I'd probably start with 3 since I know that 6 squared is already too small. And when I do 6 times 6 times 6, 3 times, I end up with 216. So the final answer there was a 3. So we started out with a log problem base 6, which I couldn't handle or deal with on the baby calculator. But because of the log properties, I was able to get it into a format I was comfortable with and then simplify it down to a single number. Similar process will happen on our next example. The bases are the same, we are subtracting, so it's going to turn into division. Be careful when you do your division. The first one goes in the numerator, the second one goes in the denominator. Now if you can, you should try to simplify that further, and we can because 2/18 turns into 1/9. If I rewrite that in exponential form, I get 3 to the what is 1/9. Now that base is turning into a fraction. As soon as you see that happening, that should be an alert to you that the exponent needs to be negative. And then 3 turns into 9. I know that that happens when the 3 has a power of 2. So if I make the power a negative 2, that'll change the 3 to a 9 and flip it over. Our next property has a number in front of the log. So we're going to utilize the very first property that was mentioned, and we're going to turn that 2 into a power on the 27. So I'm going to rewrite it as log base 9 of 27 squared. So the 2 got transformed into an exponent. Now let's try 27 squared and see what that is. See if we can simplify any further. So I get 729 when I square that. If I rewrite that now in exponential form, 9 to the what is 729. Here I would do trial and error, and I know that it's going to be bigger than 2 because 9 squared is only 81. So if I do 81 times another 9, I get 729. So my answer there again is a 3. What do you do if there's multiple properties going on? You would still use the order of operations. So if you see multiple properties, go with your order of operations like you normally would. Here I've got subtraction and addition both in the same problem. Addition, even though it comes ahead of subtraction in your Please Excuse My Dear Aunt Sally, these two actually carry equal weight. If you see addition first, do addition. If you see subtraction first, do subtraction. So that's what we're going to do here. Subtraction and addition carry the same priority, but subtraction comes first if we read the problem from left to right. So essentially we're going to do the subtraction first and we're going to hold off and do the addition later. The subtraction is going to turn this into log of 85 over 17 because subtraction turns into division, and then I still need to add log 5. Let's go ahead and simplify the 85 over 17. When you divide those out, you get a 5. So I've got log 5 here plus my leftover log 5 from before. Addition turns into, that's right, multiplication. So I'm going to say 5 times 5, which turns into, of course, log 25. That's as far as we can go on this one, and that will be the directions or the answer in some cases. On our previous examples, we were able to use our knowledge of logs to simplify down to a single number. On some of them, we wouldn't be able to go any further than this, so we're just simplifying down to a single log. Our last example is quite different from the others that we've done. You're going to be using substitution, and you have to create the property yourself. So that can be a little bit difficult for students to come up with which property to apply. What you want to do is look at what they give you and just start kind of writing those out. So I've got log base 7 of 6 that's given to me both in question form and in answer form. And then it also gives me log base 7 of 3. So I'm going to do something to those two log properties to turn it into a single log property or a single log question. So if you look at the numbers here, the 6 and the 3 simplify down in some fashion and turn into a 2. So forget about logs for a second and just think about your basic math facts. If you're trying to get from a 6 and a 3 down to a 2, mathematically, what would you choose to do? Hopefully you thought of 6 divided by 3 turns into a 2. So if we want to do division to make that 6 and 3 turn into a 2, we would need it to be like this, 6 over 3. And that's going to turn into log base 7 of 2. Well, in order to get that division with one log, I need these two log problems to come from subtraction. Subtraction turns into division. Now I'm going to use substitution to simplify my entire problem because I'm trying to find what log base 7 of 2 is equal to. Well, log base 7 of 6 is equal to this decimal, so I'm going to replace log base 7 of 6 with what it's equal to. I decided to use subtraction so that I would get my division, and then over here I'm going to replace log base 7 of 3 with its decimal. When I subtract those on my calculator, I get 0.3562, and so that's what log base 7 of 2 is equal to. Common mistake here is for kids to think that, oh, division is what I use to get the 2, and so then they divide these two numbers instead of subtracting them. To get to the 2 you needed to divide, but the two log problems got subtracted in order for that to happen. So watch out for that. Usually you will be either adding or subtracting and not multiplying or dividing.